flip something over here. Okay, so today we're going to talk about what's new in Intellect 1.4. There's a few new things, some really big, cool things, and then some smaller, minor changes that you may not have heard about. These are some of the big things that we see on this slide. Can everybody see this slide here? Or if anybody can't, other than Rick, let me know. The first major addition to Intellect 1.4 is the flexible flaw detection tool. It does pretty much what it says. It is a flaw detection tool that is flexible. And by flexible, we mean the model that you learn for flaw detection is actually flexible. This means that previously, when you did flaw detection, you had to learn an area-based model. And using an image subtraction algorithm, you could find defects. Well, now that model can be flexed. The idea being that the parts that you're looking at aren't all perfectly identical. Otherwise, you wouldn't need to inspect them. So you want to flex that model a little bit to allow some variance that's okay while still finding the defects. So we'll take a look at what that really means, and we'll actually look at that in Intellect also. The fiducial tool is another addition that people have been screaming for. This was present in Framework, and it basically allowed simple positioning so that you could quickly find the location of something, a general location, by finding basic edges. We'll take a look at that in Intellect also. But that has been added now, and it has a new feature to it, which is kind of cool. One of the other additions in Intellect 1.4 is nonlinear calibration for line scan. As you can see there in the slide, there's an image of a calibration grid. That is actually not the kind of grid that is used for the line scan presently, although that kind of grid will work. There is a line-based grid, and it basically allows you to calibrate out distortion in the X direction in line scan images. And this is very helpful for precision measurement and gauging applications. Perhaps in a web-based application where you're doing web edge tracking or measurement of items across either a web or on discrete parts. So we'll take a look at how to do that. That's something that you can play with in the emulator, so that'll be cool. And one of the last things is optimization. So this isn't a tool, but a lot of the algorithms in Intellect have been optimized. And there's not much I can show you with that. So you'll have to test it out on your own. But basically, the 5x5 series has brought about some optimizations in our algorithms so that our algorithms will run faster. And those optimizations apply kind of across the board. You're going to see those improvements in a lot of the cameras. So let's move on through this. Let's see. Where are we going next? So we'll look at some of the features in the flexible flaw detection tool, and I'll kind of gloss over these real quick because we'll look at them in a little bit more depth when we're actually in Intellect. First of all, just what is FFD? If you've used flaw detection before, it's very similar. You're basically going to image a golden part and then compare parts after that to that model. One of the differences in flexible flaw detection is that it combines both positioning and defect detection so that you can do this kind of all in one step. And there is flex built into that process so that when you find the part, you can then figure out how is this part different from the original. And you can use parameters to say how much flex is okay. And the model will actually flex to fit your new part, and then from there the defect detection will be done. And hopefully you will only find defects that are not okay while flexing to the subtle changes in your part. There are several different modes for using FFD, one of which is area-based, one is for edge-based, and then you can combine the two. So you'll see that this can be useful for finding boundary defects, surface defects. An example would be print inspection, silk screening type things. So let's bring all of these up. So some of the capabilities of FFD, real quickly, looking at geometric pattern matching, this is what object locate does, and object locate is in fact used for the positioning in FFD. You can do things at multiple resolutions. This is something that was added into object locate, the ability to find a part with a very high resolution model, medium resolution down to a low resolution. This is meant partly to allow flexibility in speed of processing and also in flexibility in actually detecting defects. Sometimes you don't want to find really small defects. So a lot of the principles of object locate are built right into the FFD tool. Here's a look at what Flex actually is. And the best thing is to just look at these images, and what you can see is that the original model does not look the same on the edges as some of the new versions of the part. So in that middle image, there's some obvious defects on the bottom right, some very large edge defects. But at the top, the model doesn't quite fit the part, but this isn't a defect. So the right image shows that the model that we originally learned has actually been flexed to fit the new part. This means that the defect detection can now ignore that because the flex covered that small variation, which is an acceptable process variation. You'll also notice that on the bottom right, those parts of, or I should say those areas of the part that are obvious defects did not flex. So clearly there are some parameters that allow us to set kind of a maximum amount of flex that we want to allow so that we can still find the defects. And we'll look at those when we get to Intellect. I'm going to skip over the rest of the slides that have to do with flexible flaw detection and leave those for you to look at. We will move on to actually look at some of the other changes before we get into Intellect. So one of actually, I should mention the compatibility with FFD. FFD is not compatible with all the cameras. It is new in Intellect 1.4, so you won't see it in previous versions. It is compatible, though, with the 535, 45, and 550, not with the 515. The 515 being a little bit less powerful in processing than the others, wouldn't run too quickly with this algorithm. It is a fairly intensive algorithm. The color cameras, 535C, 45C, and 54C will run it, as well as 554 and the line scan. If you weren't aware, the 545C and 35C are new cameras. So although those aren't changes in Intellect, Intellect does support those new cameras now. So if you weren't aware, there they are. We've got two new cameras for you, color cameras. So one of the next things to talk about is the fiducial tool. The fiducial tool is something that was present in Framework, and it is a speedy edge-based locating tool. And it basically allows you to draw a rectangle around a region of interest and scan in from all sides to find those edges. Once it finds a single edge, it kind of sets a bounding region at that edge, and it does the same thing on all four sides. The end result being that you can close in or clamp in on a section of your image and find the center point of that bounding region that was found by the fiducial tool. The name implies that it would be looking for some kind of well-placed fiducial from which you can position. It doesn't have to be a fiducial. In fact, a lot of people use this for OCR. Now, part of the reason for reintroducing this is not only was it a powerful tool because it was very fast and very simple, but also because on our readers, some of you might be aware that the readers, such as the Intelligent Scanner and the Extreme Scanner, did not come with any positioning tools. So we have introduced this as a great way of doing positioning with OCR. If your OCR moves around in the field of view a little bit, you can throw a fiducial tool down and very quickly find where that OCR is. And then you can position the OCR tool on top of that. So we'll look at a cool example of that in a little bit. Next thing we'll move on to is talking about nonlinear line scan calibration. This calibration routine, you'll see as far as the UI is concerned, is very similar to what already existed in Intellect. What's very different, oh, went too far. What's very different is the grid that you use. Instead of a dot grid that you use in Intellect, or perhaps a checkerboard grid that you might be familiar with from Insight, this uses a line grid. It's just a bunch of lines. Um, the key being that all the lines are the same and they're evenly spaced. You put this in front of the camera, tell it to train. You can optionally tell it what the pitch is between the lines. So that's a pitch from center to center. And the camera will calibrate out lens distortion, and it will also calibrate real-world coordinates in the X and Y direction. Now, the X direction is the main thing it calibrates. In the Y direction, you have to more explicitly tell what those coordinates are going to be, since in a line scan, there is no set aspect ratio between X and Y. So we'll take a look at an example of how to use that for a high-precision measurement. And lastly is the performance boost. And this is just some of the numbers for you to take a look at. But in general, on the 5x5 platform, there was an improvement on memory management for the line and edge tools, so those are going to run a little bit more efficiently. And the processor cache on the 5x5 models was increased. This is a firmware change, not a hardware change. All this means is that the firmware is basically reallocating the usage of that cache. Cache is very high-speed memory. So you'll see a performance increase on some of those tools. Specifically for 1.4, there's about a 30% increase in the speed at which the 545 runs over the 540, which is good because it's supposed to be a higher speed camera. And there is about a 10 to 15% improvement for the 515 and 35 over the previous version of Intellect, which would be 1.3.1. So recommend you test that out, see if you notice any improvements there. That's all I'm going to go over in the slides. I'm going to jump over to actual Intellect UI, and we'll go over some of this stuff, unless anybody has any questions. All right, let me switch over to my sharing slide here. Give this just a second to pop up. All right. Anybody not able to see Intellect? Is anybody out there at all? Not sure if I'm here.
Yeah, we're here.
Oh, okay. Just want to be sure I didn't.
Yeah, we're here.
Right,
here it comes.
Well, it might take just a moment to get up. I do want some feedback here as to what y'all can see on the screen. What's the rightmost and bottommost part of the screen you can see?
Well, I've got scroll bars, so in order to see all of your Intellect, I have to scroll from side to side, top to bottom.
Okay. If you don't scroll, what's the rightmost thing you see?
It would be just a little bit past the edge of the sampled image display, and at the bottom, just the top of the result table. So the title bar of the result table.
I'll try to keep everything contained in that area then. So the first thing we're going to look at is the FFD tool. That's flexible flaw detection. This is actually a fairly complex tool in that there's a lot of parameters going on. We've tried to simplify it as much as possible, but it's a pretty advanced algorithm. So you can't get away with having too few parameters. So we'll go over this first because it can be a little lengthy. I'll gloss over it and show you the basics of it. I believe previously, but also later on throughout the year, there will be trainings online that will focus specifically on the flexible flaw detection tool that will go into a little bit more depth. And, of course, we can always help you a little bit along the way. So what I've got here is a gas cap, an auto gas cap. It's just flipped on its side. And as I go through these images, see, they're basically the same, but there are some subtle differences in them. This image in particular, image 4, has some flashing on the side that's coming out. And you can see that the background is also pretty dirty. So this apparently would be a pretty easy inspection. You just need to find some stuff that's sticking off the sides. But there are some subtle variations in that edge which we'd like to account for. So first of all, I'm just going to draw the FFD tool around it to learn this area. So let me zoom in real quick here. So you can see that it draws a green boundary around the edges that it found, just like what object locate would do. So this hints right away that we're going to be using some kind of an edge-based model. Now, one of the first things that you want to look at in this tool is the training tab. So this is where you control which image you train. At the very top of this, we have the choice for area-based, edge-based, and edge and area-based. So by default, it's using area-based, which means it's not going to find defects along the edges. And what I mean by that is it's not going to use the line segments learned by object locate as its defect model. Instead, it's just going to use the grayscale values of pixels. So that's the default mode. If you switch to edge-based, then it will use only the edges to look for defects. So it's going to look for, or I should say it's going to search for all the edges it can find in the image and then compare those to the edge model that it's stored. Optionally, you can use both. And I'm going to set it to that for now so that we can just kind of see everything. But you will always see the green border drawn around the part because that is also associated with using object locate. Now you can see here on the tool that some of these settings are pretty similar to kind of a combination between object locate and defect detection. For instance, the number of learning images, which is defaulted to 1 here, is something you can set higher if you want to train multiple parts as your good part. That's something that you saw from defect detection. The edge strength and edge length are things that you saw from object locate, and an image resolution, which is also an object locate, which allows you to use higher or lower resolution edge models. So if I click relearn on a lower resolution edge model, and we look at the image, you can see that border kind of got thicker, and it's because we're using a subsampled image. So each of those pixels really is a bigger subsample of the original part. I'm going to keep this on high resolution for now. So I'm going to relearn that. And move on to the positioning tab. Now for positioning, this is object locate positioning again. So these settings should be pretty familiar. You have your basic settings for the edge strength and edge length purely for positioning, not for the defect detection side. Scale change, rotation, these should all be fairly similar. As well as a, I guess you could call this a resolution bar for how quickly you want to object locate to find it. So if you want it to look for basically the first match it finds versus searching all the possible matches to really find the best match. I'm just going to leave this at quick for now. Now you can go into the object model that was found and look at these segments just like before in object locate if you want to display some of these and get a feel for what your model is. Now the Flex Parameters tab is where you really get the meat of the algorithm. Now this is pretty good. We've honed this down to only about 6 inputs, and really it's only 5. This top thing up here, the pull-down menu, allows you to select between several different recipes. By recipe I mean combinations of these input values down here. So there's 3 basic inputs, and these tell the FFD algorithm how you want to allow it to flex to match your part. So what you're trying to do, the goal here, is to allow it to flex just enough to fit your part very well to kind of even out those modest process variations, but not allow it to flex so much that it allows defects to slide through. So the 3 types of flex that we have, and these are grayed out for now. I'm going to go down to advanced. I'll explain that in a second so that we can see them better. There's 3 types of flex. One is to flex an entire segment. So an entire segment would be, or I should say an enclosed segment. An enclosed segment is something that has a starting point and end point that are the same. so a circle or a square or any enclosed shape. So the shape that we're looking at in this case is in fact enclosed, um, in that the edge goes completely around. It covers 360 degrees of this shape. So you can flex the entire segment. That means move the entire segment around so that it matches. Now the reason this is important is because you can actually have multiple enclosed segments. For instance, if you're looking at an image of Cheerios, you would have 4 different Cheerios in there, and they may not all be in the same place in each image. So each of those individual segments could be moved around to match each one as long as they are enclosed. The next type is to flex line segments. So this, instead of being an enclosed segment, it's just an individual line segment. An individual line segment may be only a part of a full enclosed segment, for instance. So if we go to our model object, you can see that our model object includes 3 line segments. If I click display on this first one, you can see that this one's actually pretty long. So the ability to flex line segments means that the algorithm can move a line segment around to try to get it to match the edges of your part. And it's only going to move it so far, and that's determined by this pixel flex. And it's the same for the enclosed segments, pixel flex. You can tell it it's okay to move this segment plus or minus 10 pixels in any direction to try and find a good match. If it's more than that, it's not going to flex it. Now, for this one in particular, the line segments, you can also set the line size. This is just a max setting for how long you want a line segment to be that it's going to try and fit. The last setting, all pixels, is the most detailed. This means that the algorithm can actually flex individual pixels so that they match your model. So this is the most precise but most time-consuming part of the algorithm. Enclosed segments, as you can imagine, is going to be a little bit quicker because you're moving a whole segment at once. It's not going to be quite as precise if within a single segment, individual pixels or segments are moving around. So you can enable or disable any combination of these to try and get the effect that you want. Now, without a lot of training or experience using this tool, there's a lot of variations you could go through with these parameters. So for that reason, we have used these recipes. So each recipe attempts to target some type of application. For instance, the default settings are just kind of some general settings that we think will work on a lot of applications. Large flex means you expect your part to actually vary quite a bit, and you want to allow that kind of large flex. If you go to print growth, this targets printing applications where the print may actually expand and contract a little bit. You want to allow that. Mouse bites, kind of what it sounds like. It's going to be small kind of divots out of the side of a part. So this is going to be very small defects. Fine detail is not just going to look for mouse bites, but it's going to attempt to set these parameters so that you find very fine defects. This is going to be the most precise defect detection. However, if your process isn't precise enough, your positioning isn't precise enough, your lighting isn't consistent, then fine detail probably won't be for you because a lot of normal variations will end up getting passed through as defects. You can set this to no flex, which means you don't want to use flex at all. If you do this, this basically means you've got a tool that is doing defect detection. At this point, if you're not using flex, you may want to consider just going back to using the defect detection tool. The last thing you can do is set this to advanced, and this means you can set the parameters yourself. So what you may find you need to do is select something like print growth, and this will get you in the ballpark, or test each of these to see what works for your application, and then come down to advanced, and it'll open up these parameters, and you can kind of tweak them from there. I'm going to leave it on default because default actually works pretty well for this image. Just some other quick things. There are image markings here so you can see what's going on. Just like in the defect detection tool, we can view the different images that are involved in defect detection. You can choose to view only the area defects, only extra edges, or only missing edges, or both. So you can actually see positive defects as well as negative defects using these missing and extra edges. Just like in defect detection, you could actually set the defect parameters, meaning what do you consider a defect? Is it high intensity? I should say, is it you can set the threshold for higher intensity pixels or lower intensity pixels that may be considered defects. You can do this based on pixel size, somewhat similar to a blob, based on contrast, and you can set individual settings for both missing defects and extra defects. So this is going to be a spot that appears in the image that wasn't there before, or perhaps a part of your part that is now missing. There's a separate setting here for the area defects. This screen should look pretty familiar from defect detection, where you can manipulate the image mask. I won't go over this too much because this is more of a defect detection topic. And the final thing is, whenever you do have defects, of course, you can come over here and actually see them. An important button here is the Ignore Selected Defects. Whenever we do find a defect, for instance, let's scroll through an image and see if we come up with one. Something down there. You can see it found a defect along this edge, and that defect shows up in the effects window. If for some reason you decided that that's not a defect, that's okay, you can actually highlight that and select Ignore Defects, and it'll forever after ignore defects that occur in that same area or along that same edge. We're not going to do that right now. And then there's some pass-fail criteria for the number of defects that are found, the flex score, so on. I won't talk about that right now. So let's take a look at these images and the results. I'll go back real quick. So you can see that this is the one that we learned on, and I'm just going to go ahead and relearn this in case I changed any parameters. As we scroll through this, you see that it found a defect here. I'm going to turn off markings real quick so you can see it more clearly. So that looks like a pretty obvious defect, and it did a good job finding that. Now here's some made defects. Now these are pretty obvious. And you can see part of this actually falls outside of the learn region, but that's okay. But some stuff that's maybe not so obvious is this defect up here. Now this may or may not be a defect to us. This little hump looks more like just normal part variation. So this is the point at which we would probably want to go into the flex parameters and tweak them a little bit to allow this defect to pass through. You can see from the markings, it found that as a defect. However, over here, where we have a red spot where the model didn't quite match up, it didn't find that as a defect. So our flex parameters are kind of on the threshold of allowing this to go through, but not allowing the one on the top right corner to go through. So that's something that we could edit. We've got defects that we found over here on the left, so it's doing a good job of finding those. Noted that it found actually these two, but it didn't find this corner. So it flexed this corner a little bit. And I'll show you here in a second exactly what that flex really looks like. Now one thing you'll notice is that it found a defect in the background. This obviously is not a defect in our part. This is just noise in the background. So there's two ways we could handle this. One is to go into our defect list and select that and hit Ignore Selected Defects. If I do that, you'll notice this defect is no longer there. That would work just fine, but if defects appeared in other areas in the background, I'd have to hit Ignore for every one of those. So the better way of doing this is probably to edit the shape a little bit. If I click on that shape, notice that the composite shape box down here, we can actually go in here and just subtract out some regions that we don't really care about. So I can subtract out that region, subtract out this region. And now, when we go through here, these two regions, of course, move hard as object locate finds them. They get ignored. And I've ignored a little bit too much here, but actually it doesn't matter in this scenario. But you can, of course, edit these boxes to be wherever you want. They don't have to be rectangles. They can be poly shapes, polylines, whatever you need them to be, conform to your shape. Now, something that I want to point out here is the difference in what Flex has done versus if we're not using Flex. To test this, I go over to Flex parameters, which is currently set to default. I'm going to choose no Flex and hit apply. one thing you'll notice, let me find a good image for this, is that some of these edges don't quite conform. You can see down here, the edges where the red pixels are places where the original model doesn't quite fit this new part. These could have been found as defects. Now, because of our settings, it's okay. Now, if I go back and enable flex by setting this to one of our models default, you see that those edges have been flexed over. So now our model, because of the flex, conforms to this new part within the variation that we've allowed. So that's kind of the meat of the flex algorithm, the ability for that model to be changed. That's kind of a gloss view of flex. Does that make sense to everybody, or anybody have questions? I know some of you might have seen this already.
Well, seems to make sense to me. Kind of pretty cool.
It is pretty cool. We hope that
Frank's connection just dropped out. He'll be right back on.
Okay.
The moderator has disconnected. At this time, the conference will be terminated. Thank you and goodbye.